Welcome back to the lecture series on digital electronics, which is subject in third semester, Diploma ETCE, course code ETCE/DE/S3. I am the course coordinator, Paulusri Dhar, Assistant Professor, Department of ECE, Guru Nanak Institute of Technology. And my email ID is paulusri.dhar@gnit.ac.in. So we are going to start lecture 7, which is a in module 1 number system and basic logic gates. So we are going to start NOT gate today, which one is a basic gate. Now before starting NOT gate, let us have a quick recap of the previous lectures. In the first lecture, we have studied about the syllabus of the digital electronics and also the differences of the digital systems and the analog systems, and also the advantages and disadvantages of the digital system. Next, we have studied about the number systems and how to convert the from one number system to another. Basically, there are four number systems: the binary number system, decimal number system, octal number system, and hexadecimal number system. Now we have done several numericals which makes us clear how to do the conversions. After the conversions, we have done the sign magnitude form of the negative numbers. That is how to add a sign bit and to make the number a negative number. That is, a sign bit decides whether the number is a positive number or a negative number. And next is we have seen the complement forms, that is the 1s and the 2s complements, and also we have done the binary additions or the binary arithmetic, that is the binary addition, binary division, binary multiplication, and the binary subtraction. After this, we have come to the basic gates. In the previous lectures, we have studied about the AND gate and the OR gate. In the AND gate, we have studied about the truth table, the logic symbols, about the logical multiplication, what which we are doing in the AND gate, about the IC, about the pin configuration of the TTL logic family IC. Next, in the OR gates, we have studied about the applications of the OR gates. Next is the 2 input OR gate, 3 input OR gate, 6 input OR gate, and also some real world examples related to the OR gate, like the switch circuits. How to that is the switching circuits related to light on and off. Next is the applications of the OR gates, that is related to a car lock system, like this. Now we are going to start the NOT gate. The NOT gate is also known as an inverter. The NOT gate has one input and also one output. From all the gates, only NOT gate is the basic gate where there will be one input and only one output. The output is always the complement of the input. Now this figure show the logic symbol. This is the logic symbol of the NOT gate and the truth table of the NOT gate. Now the output of the NOT gate is logic 1 when its input is logic 0, and assumes logic 0 when the input is in logic 1. That is, it is a device whose output is always the complement of the input. That is, this is the Boolean expression of the inverter. That is, x is equal to a bar, where a is the input, x is equal to a bar. That is the complement of the input. The output is always the complement of the input. So here we have seen the logic symbol of the NOT gate, truth table of the NOT gate, where a is the input and x is the output. When a is equal to 0, the output is equal to 1. When a is equal to 1, the output x is equal to 0. Now, the symbol for the NOT operation is a bar. This is the bar. As I already have seen that x was equal to a bar. So the symbol of the NOT operation is the bar. When the input is a, the output is equal to a bar. Logic circuits of any complexity can be designed using AND, OR, and NOT gates. That's why these are called the basic gates. What are the basic gates? AND, OR, and NOT gates. Logic circuits that use these three gates are known as AOI logic circuits. Why it is called AOI logic circuits? Because it is the full form of AOI is AND, OR, and invert. Invert is for the NOT gate. Why? Because NOT gate is also known as the inverter. This AOI circuits is a very important term used in digital electronics. Next is the logic circuits that use only AND and OR gates are also called AO logic circuits. That is, A stands for AND and O stands for OR. That is AND OR logic circuits. Now this is the TTL logic IC. The TTL logic IC used for NOT gate is 7404 IC, which is a hex inverter. This IC is also known as a 7404 hex inverter IC. This IC is a falls in the TTL logic family's IC. What is the full form of TTL? It is transistor logic. So again, this IC is a 14-pin IC. Here is the notch, and after the notch, the pin counting starts from here. That is 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, and 14. Now, this is the pin configuration of the hex inverter. Now, keep this in mind that this IC is known as hex inverter. Why it is called so? Because this particular IC consists of 6 number of NOT gates. This is first, second, third, fourth, fifth, and sixth. That's why this IC is called hex inverter or 7404 hex inverter. This is the pin number 1. Pin number 1 is the input output of the first inverter, and this is the input output. This one is the input and 2 is the output. Next is 3 is the input and 4 is the output of the second inverter. 5 is the input of the third inverter and 6 is the output of the third inverter. 7 is the ground. 8 is the output of the fourth inverter. 9 is the input of the fourth inverter. 10 is the output of the fifth inverter and 11 is the input of the fifth inverter. 12 is the output of the sixth inverter and 13 is the input of the sixth inverter and 14 is supply voltage. That is the positive voltage which falls in the range of 4.75 to 5.25 volt. Also, it is the name of this pin is VCC. That is, it's connected to a positive voltage, supply voltage. That is 5 volt and it ranges from 4.75 volt to 5.25 volts. Now, we are moving to the NOT gate applications, which is also a very important term. NOT gate produces reverse output of the input. So, they are also known as inverters. This is the first point. What is the second point? The CMOS inverters are generally used in designing of oscillators. They are used mostly because of their low power consumptions. The CMOS inverter is a very important term. What is the full form of CMOS? Complementary metal oxide semiconductors. This CMOS consists of NMOS and the PMOS. Another advantage of the CMOS inverter is that they can be easily interfaced with other logic devices. Normally, nowadays, we are using CMOS inverters to design every circuit. CMOS inverters can be used for designing the counters, the flip-flops, like this digital circuits. The CMOS inverter circuit is designed in a ring format to produce oscillations like the square wave oscillator. The frequency is given by F is equal to 1 by 2 n into T subscript of P, where n is the number of the inverters used to construct the oscillators and T subscript of P is the propagation delay of each gate. This propagation delay is very important term. What is the meaning of the propagation delay? Propagation delay means, suppose I am having a gate. Suppose the name of the gate is A and the input is B, output is C. So when we are giving the input B and we are getting the output C, in between this getting the output, there is some delay. That is the propagation delay. That is the input traveling through the gate will have some delay. This is the propagation delay, and which is a very important term in digital electronics. So what we have seen in today's lecture, that NOT gate is an inverter. This is the logic symbol of the NOT gate, and this is the truth table. The output is always the complement of the input. Next, the symbol of the NOT gate is a bar, and the input is always the complement of the the input is A. Suppose the output is always the complement of the input. Now there are two types of logic circuits, AOI logic circuit and AO logic circuit. AOI logic circuits are AND or inverter logic circuit, and AO logic circuit is the AND or logic circuits. And as all of the logic circuits can be designed using the AND, OR and NOT gates, so these are known as the basic gates. This is the IC, that is the hex inverter IC, which consists of 6 number of NOT gates. This is the pin configuration, and after that we have studied about the NOT gate applications, which are also quite important in the case of a digital electronic subjects. So thank you all for being with me. Thank you.